Hello, good morning, everyone. Good afternoon, good evening. Welcome to the Spring Working Group. Thanks for coming. We'll have a full agenda today, so we'll start on time. This is the note well, so not something new, but you need to be well aware of it because you already agreed to comply. So it's interesting documents on subjects. A few tips for the meeting, nothing new, but just for in-person participants, if you are in the room, you do need to connect to the data tracker on Mitecolite to fill the blue sheets and also to be able to join the queue for the mic. So we have a shared queue for in-person and remote participants. We are taking the minutes collaboratively, so thank you to Shopping for taking the minutes. You're welcome to collaborate. At minimum, you can read correct, especially your name and your comments. In terms of document status, we did an adoption call on distributed SRv6 locator by DHCP. It has been just adopted and published. In terms of ISG review, we have the pass segment in MPLS-based segment routing network, which has passed IETF last call and is on the agenda, ISG agenda for telechat end of this month. In terms of SR replication segment, the ISG has approved the document in August. It's now in RSC editor queue. So thank you to the editor and to the ISG. And finally, we have a new RSC, which is integration of network service header, NSH, and segment routing for service function chaining.
Hi.
We do hear you. So this is the agenda for today. We do have a full agenda. So we like to remind all speakers that the time they have for their subject includes both the presentation and the questions. And part of the goal of the meeting is to be able to discuss the topics. So please keep some time for the discussion. Any comment on the agenda? If not, we'll start with the working group documents. And first one is compressed SRv6 list, segment list encoding, SRH. Is it Francois or Wekyong? Okay, Francois?
I'm going to present that one. Can you hear me well?
I'm going to share, yes.
Yeah, thank you. Okay, thanks. So this is Francois Claude Cisco, going to give you an update on where we are with this compressed SRv6 segment list encoding document. Next slide, please. Thanks. So first of all, on the issues. So if you remember, we had five issues that we are tracking on the GitHub. After the last IETF in San Francisco, we had a poll to close them. And as a result of that poll, we closed 4 of them. So number 2, 3, 4, and 5 were closed on August 24. There is one issue that remains open today. This is issue number 1 on the clarity on one or multiple data planes. So on that one, there was also in the poll strong support to close it, but there were also some outstanding technical comments at the time. So now all of these comments have been replied to, and there was no further discussion on the topic on the list. So perhaps we could close it as well, and that's really a question for the chairs. Okay, next slide, please. So regarding the reviews, we got multiple reviews on this draft. Thanks a lot, Joel, for arranging that. it's good to get all of these thorough reviews. I would also like to thank all of the reviewers who spent a lot of time going through the draft and trying to understand it. It's a long draft, so it's really a significant effort to review it, and we are really grateful for the work that has been done. In revision 09 of the document, so that is the latest one, we addressed all of the review items from Linda and from Andrew, and we replied to the review emails explaining how we addressed their comments. We also partially addressed the review from Adrian and from Boris. So for Adrian, we're about 92% done. For Boris, about 80%. There were a lot of review items, so it's taking some time. Please bear with us, but we're progressing on that. So again, thanks a lot for all the reviews. Next slide, please. So now I'm going to go through the changes that we made since the last presentation in San Francisco. So we did many editorial clarification and fixes in response to the comments and the reviews that we got. I'm not going to go through all of them. There are too many, but I will highlight the most important ones. So in section 1, we removed the reference to the design team compression requirement document because that one is expired and is no longer maintained. So we replaced it with a short summary of the rationale for performing SRv6 compression. And speaking of references, we also added a reference to the draft IETF 696, which talks a bit about SRv6 compression. So that would be a useful read. Next slide, please. Then in section 4, so section 4 is the one that talks about segment endpoint node operation. So here we clarify that the seeds that have the next CSID flavor and the seeds that have the replace CSID flavor can coexist on the same segment endpoint node, but they can also coexist in the same segment list and even in the same compressed seed container. In addition, we also added a high-level description of the next CSID and the replace CSID flavor. We understand that going through the pseudocode can be quite difficult, and it can be hard to get to understand the high-level mechanism of compression. So we are now explaining that in plain English to help understanding it. We also clarified how the pseudocodes in this section 4 combine or augment those in RFC 8986. And as a reminder, you'll find the full combined pseudocode in the appendix of this document to really understand how that all fits together. Next slide, please. So then in section 5, we clarified the definition of the global and local CSID. We got a few questions about that in the reviews, so we try to improve the text. Let us know if that works. Then in section 6, we expanded on the description of the compression algorithm to try and help the implementation of it. So we added a more detailed explanation. And finally, in section 9, we merged the two subsections 9.1 and 9.2. So these two are about pinging a seed with or without a segment list. But it's really essentially the same thing. So we merged them together. Next slide. Okay, so regarding the next step, we will continue to address the remaining comments that we got as part of the reviews, and we'll get the draft ready for working group last call. In the meantime, we would also like to solicit feedback from the working group on the latest changes that we made. Hopefully we improve things, so let us know if that works. Thank you.
Okay, thank you. I don't see anybody in the queue. Are there any comments on this? I am checking with the various folks who did provide comments to make sure that they are comfortable that their comments and concerns have been addressed, because I can't judge for other people. I very much appreciate the efforts from the editors to address the comments they have received, and I know it was a lot of volume, but I also very much appreciate the reviewers for putting in that much work. So thank you to all sides, and we hope to keep this moving. We do want to get this one done.
Thank you, François. Next is circuit style segment routing policies.
Hi, good morning, everybody. My name is Christian Schmutzer from Cisco, and I'm presenting in place of the authors. This is about circuit style segment routing, and I would like to give you a quick update. The draft got adopted lately, and essentially the focus was on making sure that comments that were raised during the adoption call got addressed. I have a few highlights to point out here. From a content perspective, we added the creation of the policies using BGP. So that's a fairly bigger change that happened. We also now mention in the introduction a bit more clearly what the use case is, which is basically a bunch of pseudo wires that you would run over circuit style policies in a typical scenario. And then we had some discussion on the bandwidth and its commitment. We went ahead and changed the wording a bit to not necessarily use the word commitment and clarify what is being done, and essentially we're not doing anything different to what we have done for many years in RSAPT networks so far. And then of course a couple of changes here and there as always. Next slide. Oh, okay, sorry. Oh, okay. So talking about the bigger change, which was sprinkled across the whole document, is essentially documenting that circuit style policies can also be instantiated using BGP. Essentially, we are leveraging already existing definitions in other documents. Essentially, a centralized controller would perform path computation as well as the bandwidth bookkeeping for the intended circuit style policy and instantiate it at the headends using BGP. Because now everything is driven from the controller, the headends don't need to signal the desired diversity and co-routing and bidirectional constraints. So essentially, those signaling extensions in case of BGP are not needed. The creation is using the SR policy NLRI defined in the IDR segment routing T policy document. And based on the protection and restoration scheme, you would either send multiple NLRIs or a single NLRI. Reporting would be done with BGPLS, and we're going to use the C, A, and B flags to indicate whether a path is active and carrying traffic. The C flag, is indicating that the path came from a controller, and the B flag would be if the candidate path is a backup path. So all in all, I think quite straightforward, and the respective changes were done throughout the document. Next slide. A bit of a shameless plug for private line emulation, but maybe related to what I mentioned, that we made now a statement in the introduction that one prime use case is pseudo wires over circuit style policy based on a comment. I wanted to highlight to this group here that actually in PALS there is some work going on for bitstream pseudo wires, which I think are a good candidate and a typical deployment we will see that will leverage the circuit style policy in the network to sustain the bandwidth as well as give the desired path behavior. Next slide. At this point, this is actually all I had. Thank you very much for all the comments and your review. I think the document is more or less stable and straightforward. So I'm potentially even asking the group to consider going to the next step, which would be a work group last call. Thank you.
So, hello, this is Wei Jiangcheng from China Mobile. I think it's a very valuable draft. So I have one comment. I'm not sure if you know, there is a new security solution have been published by ITUT named MTN. The standard is G.8312. I think if it's possible, you can add this kind of security solution in the draft also. That would be helpful for the operators who are using MTN. Thank you.
Okay, thank you.
Any more comment? So this is a relatively new document. So we'd like to have more comments and review on the list. So if you could possibly ask for review on the list to solicit
Yes.
comments.
Yeah, I will do, yes.
Thanks. Okay, so next slot is about SRv6 operational security. We should have Nick. Thank you, Nick. This is not a working group document, but it is a request, specific request for ISG. So we'll spend the time we need on the agenda. Nick, up to you.
Yes, hello, Nick Braulio. I'm going to talk about this very early draft that we're writing here. As a result of a request from ESNet. So next slide, please. All right, so we had some pretty specific goals, as the title slide said, and we're gonna try to create a draft detailing the operational security considerations for running an SRv6 production network. So we want to have an unbiased view of what that looks like. We want to provide an outline of the real practical security considerations for doing so. Running this in production, and create a referenceable draft so that when folks need a reference to get started, or they have some gaps in what their operational knowledge is, they can reference this, and hopefully it will provide them with the guidance that they're needing. Next slide. So where we are right now, as I said in the very beginning, this is really early. It's not a working group draft yet. It's still has some unfinished sections. Definitely needs polish. We've got first pass of the risk profile, and we've got, like I said, an outline of what we think are at least the important touch points so far. Next slide, please. So since there is no link, I was remiss in getting the draft published, as I said on the list. So apologies for that. Through some example topics that we've got in there. The draft is now available on Data Tracker, so you can actually go and look at it. But just high level recap here. We talked about encapsulation, tunneling, source routing issues, the header, filtering considerations, and a handful of things. I'm not going to read all of them. You can take a look there. You can go and look at the draft, which I think we can put a link to in the list too, since it wasn't available for the slide deck. Next slide, please. So this is really the point of me talking right now, is to ask, what we would like from you, which is we'd like some folks to read it. Give us your input, to please take into account it's very early, so we need your input to help guide us to make sure this is the best document it can be. So read it, give us some suggestions. Our plan is, learn what we can, adapt to what you tell us, write it all down, do it again, refine it, and then hopefully adopt it. Next slide, please. So the current repo is public. It's in my personal GitHub account. There's the link to that. You can see it there. It's also now a data tracker. Pull requests, obviously welcome. Reviewers encouraged. And the bottom link is just the the HTML version. Makes it a little bit easier to read. It's the same thing that's in the data tracker now. Next slide, please. That's how you get a hold of me. You can look at the draft's author list. We have a handful of folks that have been working on it, and I think it's a really good mix of folks. But input from you would be great, and is hereby solicited. Next slide, please. Yeah, left lots of room for questions on this one.
So we do have comment. Lisong Liu, if you want to comment.
Oh, sorry. Hello, I'm Yisong Liu from China Mobile, and Daniel from Canada and I have proposed a draft about the SRV6 security experience. You can check and see the draft, and we have discussed how to protect the seed list and SRH within the operator network. So we think that there is no risk in we both have deployed the SRV6 in our network, and we think that there is no risk with the SRV6 deployment. You can check the detail in the draft. Thank you.
Thank you.
Hi, Eric Vink. So Nick, it's really an early draft for you. Must be 3 a.m. or something for you.
It's just before 3 a.m.
Okay, congratulations on this one. And congratulations to start it. Just wanted to say there are at least 2 other RFC. One which is 6169. I will send you an email. Written by Suresh and Dave Teller years ago about the security of IP tunnels, which is quite similar. So you may want to reuse some text. And the other one, shameless plug for my own RFC 1999, which is IPv6 operational security consideration to operate an IPv6 network. As we should
Yes.
This one is an important document.
Thank you. Yes.
Thank you, Eric. Can you copy the list, please? Thank you.
Hey, Nick, Darren Dukes. Just wanted to thank you for the outline so far. It looks good. It looks a bit like a subset of what was in 8754, which is at this point very much expected. The IESG and I had a lot of conversations around that document as it was getting published. And I was going to say, if you're looking for additional help, I'm happy to contribute, but I see thankfully you're taking pull requests, so we'll jump on there and give you whatever help we can. Thanks.
Appreciate it very much. Thank you.
Robin?
Okay, yeah, Zhen Bin from Huawei. This is my comments. In fact, now, because SRV6 has been proposed more than 7 years, so I think it's already not the paperwork. And in fact, according to our statistics, until end of last year, there's already more than 160 deployment all over the world. And I emphasize that because this is not only the operators all over the world, but also I emphasize in China, the 6 most important banks also deployed the SRV6 in their networks. And in the process, there's the few security issues. And so that's my suggestion for the author team. I think it's better that the author team can communicate with the operators or enterprise who have deployed the SRv6 and learn their opinions on the SRv6 security issues. Second, on the Monday, we had a successful SRv6 operation meetings, and operators share their experience of SRv6. I also hope that we are also encourage that the operators who deploy SRv6 initiatively to share your experience to the author team and help them to refine the work. Okay, that's my comments.
Yes, thank you. That would be wonderful. We could get that input from those folks.
Jimmy's next. And Robin, if you want to contribute on share, please send to the list, especially everything that has been interesting in your side meeting.
I'll try.
Thank you. Jim.
Jim Guichard. Nick,
Closer to the mic.
what's that?
Get closer to the mic.
Okay. Jim Guichard. Nick, thank you. I'm the AD responsible for this working group, and I just wanted to say thank you very much for stepping up, you and the team, to work on this document. It's very much appreciated. What I will say is that the purpose of this document is not to go after security in any kind of way to say, oh, this is a terrible thing. The purpose of this document is that I want to see somewhere documented what the security considerations are so that an operator can read that and make their own informed choice. That's the only reason for this document. So, you know, I'm not expecting to see solutions or anything like that in the document. I'm just expecting to have, you know, a well-documented considerations that people can read and make their own informed choices. So discussion about this operator does this operator does that is really not appropriate in this case. That's not the purpose of this document. So I just wanted to make that clear.
Yeah, agreed. I do want to point out it also serves as input to other documents that work on SR and need to provide security considerations. But it is not a survey of the field. It is not a set of recommendations for techniques. It is an evaluation, and I very much appreciate that the outline that the editors have been putting together is aimed at being an outline. Now go ahead, Rachel.
Yeah, very short comments. So as just now Robin mentioned, we, Daniel and I organized SRv6 operation set meeting, and that set meeting, 5 different operators from around the world to provide some experience on SRv6 deployment and operation. I think there are several very good materials that can be the good input for the draft. In those materials, I think the basic conclusion is that SRv6, like other tunnel technology such as VXLine, GRE, something like that, there's no any deployment issue or security issue. And if you follow the SRv6 architecture requirement within the trusted domain. So thank you.
Thank you.
Any other comment? So again, we'd like to thank very much the authors, and in particular Nick. They did their best to start quickly and to have a draft for this week, although a bit late for the deadline of the draft uploaded, and to present even at 3 AM in the morning. So Nick, thank you very much. And we expect additional work, so you'll have more work and possibly more pain on that document. But thank you very much.
Thank you.
So next is about, so we finished with working group documents, or kind of. We are moving to individual documents. And next to you.
Okay. Good morning. I'm Yao Liu from ZT, and I'm presenting extending ICMPv6 for SRv6 related information validation on behalf of the co-authors. Next, please. And as we know, SRv6 can be related with many extra information such as VPN, eVPN services, SRv6 endpoint behaviors, flags algorithms, service functions, and etc. And in SRMPRS or MPLS, there are also the MPLS label or sys can also be related with many extra information. And in SRM pairs, there are mechanisms in LSVP to verify the data plan against the control plan. So when a new feature is defined and a new FEC, normally a new FEC sub TLV is defined with the new information related with the set encoding net, so the mechanisms can still work. And in SRv6, there's no similar mechanism. So this draft aims to define ICMPv6 messages to verify the data plan against the control plan for SRv6. Next, please. And two new ICMPv6 messages are defined separately for the request and the reply. And in the request message, one or more validation information objects are included to carry the information related with the sys to be verified. And in the validation reply, the return code indicates a validation result, so such as validation pass or not pass or malformed packet and something else. Next, please. And here are the detailed structure of the validation information object in the request message. It is a new ICMP extension structure and a new class number is required. So it can indicate it is a validation information object. And the C type in it indicates the type of the information that needs to be verified. And the object carries the C type specific data. Next slide, please. Here are some object payload for, here are some typical object payload. The first, most are defined taking examples by SRMPLS LSVP and its FEC sub-TLVs. And the first is SRv6 endpoint behavior, and the next is for IPv6 prefix IGP algorithm. Next, please. And this is for SRv6 IGP adjacency. Next, please. And the object payload for VPN v4 prefix and VPN v6 prefix are also defined. Next, please. And here are the main processing procedures. And it's kind of like a pin in a set. So the first is to send the validation request. And the SRv6 to be verified is set as the last segment. And in this use case is a set C that needs to be verified. And the second is when and the intermediate nodes like node A and node B just forward the packet like normal IPv6 data packets. And when node C receives the validation request, it found that the destination address is locally configured as a segment, and the segment left is 0. So it's process upper layer header, which is ICMPv6 validation request, and it verifies the information encoded in the validation information object. And the third step is after validation, node C sets the return code based on the validation result, and the validation reply message is sent to the center, and it's IP rooted. Next, please. And this draft has been presented in IETF 116, and here are the main changes in then. The first is we claim that this draft, there's an update to IFC 4884. So the ICMP extension structure can be carried in the new ICMPv6 messages. And the INR section has been refined as reviewed by other experts, and we add Ethan Liu from China Mobile as an co-author. Next, please. And here are the next steps. Currently, we only define some typical object payloads. So we would like to add the new types of object payloads for validation, such as EVPN information related with SRv6 and maybe SRv6 pass segment. And we are considering about whether to add some more detailed error information in the reply message. Currently, there's only a code. And we request feedbacks and comments and welcome cooperation. That's all. Thank you.
Go ahead, Zafar.
Zafar Ali from Cisco Systems. So when I worked on, I was editor for the O&M for SRv6, so 9259 RFC. So we did discuss, or we thought about these things, and the goal was to make SRv6 O&M to really rely on the base IPv6 O&M techniques. So in base O&M for IPv6, we also have this RFC 5837 that talks about more information that could be provided in terms of incoming interface identification, where the packet is going, and all. So my one comment is that overall, holistically, we should think about that whether we want to rely on the native IPv6 or we want to create something for O&M for SRv6. But before to that answer, what was considered during that RFC writing is in MPLS, we have this experience and issue that when we define a new FAQ and network is deployed, it's very difficult to introduce new O&M mechanism. So over time, like we learned from time when we start defining this control plane and data plane validation in MPLS to now, what our experience have shown is that it's very operationally very complex to upgrade every time you do a new type of SAID or new FAQ. It's very complex for that. So actually, it is interesting that there is a work going on in MPLS working group for MPLS O&M that basically generalizes that we need to do, O&M job is to do control plane check, and it generalizes the FAQ so that you can just do data plane. Sorry, O&M job is to do data plane check, and it generalizes MPLS O&M to do data plane check. And overall, people are happy with that simplification because it simplifies the network deployment. So I think my comment is that we need to really think about if we want to go this route. And what is missing from 5837 that we need above and beyond in SRv6. I hope I'm clear.
Okay, thank you, Safa. First, I'm going to check the RFC you mentioned. I suppose this RFC describes how the ICMPv6 requests can do the downstream information or the routing table. And yes, and our main purpose is also want to keep this simple. So we do not define the more way too complex structures as all the downstreams and the interfaces like MPLS LCP ping. So maybe we can add some more comparison and distribution, both on the FC you mentioned and SVP, to show that what we want to is just a simple verification, not to do that much complex.
Sounds
Yeah.
good. So just one comment is this 5936 defined close to DMM equivalent, DD map equivalent, but we can talk more offline. So
Okay, thank you.
Thank you.
I'll double check those FCs.
Thank you.
Thank you for your comments.
Ketan.
Ketan Talaulikar, Cisco. So one other input to have for the control plane validation for SRv6, we have the ability to export topology via BGPLS, right? So a controller or anybody that is consuming it can very easily validate what SID is, like, let's say the end SID or the end.x SID. This is much more, I feel this may be a much more scalable way for operators to validate consistency of the control plane. And then on top of that, the ICMP, existing ICMP v6 will validate the data plane. So perhaps marrying these two may be a way rather than bringing everything from MPLS ONM into SRv6 ONM. Just some inputs.
Yes, I think there's a little bit difference between the BGPLS. So a BGPLS is like kind of like a push mechanism. So the so the nodes in the forwarding plan, they can push their information to the controller, so they can it can verify it. But if a mistake occurs, and the controller wants to immediately check the information on the node. So, so maybe the, so BGPS maybe cannot fit that requirement that well, but we can compare with this mechanism.
Okay,
So,
we can discuss offline. What I
Okay.
meant is that the control plane validation is done via the topology that is received,
Okay.
and then use ICMP v6 for the data plane validation. So both together.
Okay, thanks.
So thank you. It's an important subject to be able to operate networks. So thank you for doing work. I would suggest network operators which have already deployed SRv6 to provide feedback about what's missing to operate and troubleshoot network and services. And again, I think it would be interesting for you, just for information, to look at what MPLS working group has done, because they have something like 20 years of experience, and probably some part and some feedback would be interesting to do something or different. But experience is interesting. Thank you for the work. Next is EVPN fast preroute.
Good morning. I'm here this morning to present EVPN fast reroute on behalf of my co-authors. This draft is being presented here in Spring for the first time. It has been around in BESS for a little while now, but very recently SRv6 procedures were added, and we thought it best to run it by Spring before going through a adoption call in BESS. Next slide, please. So before diving into the behaviors of SRv6 in this draft, I'll give a brief overview. The motivation for the draft is convergence in EVPN. So convergence in EVPN, especially EVPN L2, L3, is control plane driven right now. So there are several straightforward solutions that exist, right, using peer service labels and effectively using information that is currently available. But these solutions, these easily accessible solutions, have drawbacks. Two examples are, for example, that they may lead to loops in the network, micro loops in the network, and they also do not work for all the EVPN load balancing modes. So As it stands, EVPN convergence is very hard to get to the reasonable set of sub-second or even at times extremely aggressive convergence targets. So the support for SRv6 underlay was recently added to this draft, I believe last spring. And this was done as two new behaviors. And in the next two slides, I'll go over basically what had previously been termed just attributes, the SRv6 clarification brought to the draft terminology for these two behaviors. So on the next draft. So the first behavior of the redirection in EVPN, and you'll have to apologize, I'll have to apologize for the use of the term label here. The draft came from MPLS underlay, but we're talking here service SID and reroute SID. So if you think about, you know, in EVPN, a multi-homing environment represented here by PE1 and PE2, all active, single active, whichever load balancing mode. If the failure happens, for example, this is the easiest one to describe, right? If the failure happens on the access side, on the CE side, effectively both links at P1 and P2 will be seen as going down fairly simultaneously. And what's going to happen with the straightforward solution is both P's are going to encap reroutes to each other, and this is going to create a micro loop. So the first behavior of this reroute is the behavior of what we call terminal disposition, right? So once a reroute occurs, that reroute SID disposes terminally, right? There is no further reroute possible using that SID. So that the once rerouted packets do not go through another reroute. Next slide, please. So the second behavior, which is specific to EVPN and EVPN load balancing, in EVPN, when you have P1 and P2, EVPN will do what is called a DF election, right? To select a designated forwarder between P1 and P2. Now, if I do a redirect from a failed PE, P1 in this case, who happened to be the designated forwarder for the traffic, and I do a redirection to PE2, who is the non-designated forwarder. PE2's reaction is, like I said before, control plane driven. So PE2 will only learn about this failure at P1 at control plane speed, whatever that may be, but hundreds of milliseconds at best. If I do a redirection at P1 at effectively interface down local detection speed, I'm going to be rerouting traffic right into a blocked or down interface at P2. So there's no real gain there of my redirect. So the other behavior that we're defining is effectively this bypass tunnel or this bypass SID does what we termed as DF election bypass. So when that packet arrives at P2, the P2 behavior for that SID is to bypass the DF election specifically because it knows it is a rerouted packet. So the main benefit of this is for single active load balancing because single active does bidirectional blocking of traffic, but it applies equally to all active, single active, port active, and so on. On the next slide. So the SRv6 support that we added very much mirrors what we did for MPLS, right? So a first SID is going to be signaled, that is the service SID, whether that be n.dt2u or n.dx2, for example. And alongside with this, a second SID, which constitutes of effectively the service SID with an attribute, in this case, the reroute attribute, argument, sorry, the reroute argument is going to be signaled together with the base service SID behavior. So the two behaviors will go side by side, and on the peer redirect, the peer will choose effectively to re-encap with this behavior which contains an attribute. So at this point, I saw I'm over time, so I have here a couple of the benefits of this approach. But I think the most important aspect of me presenting here today is It's an important draft in the EVPN, in the BEST working group for fast convergence. What we're seeking here in the Spring working group is feedback on the SRv6 procedures that we defined and generally comment from the Spring working group for the SRv6 portion. Thank you.
Thank you. Meng Zhao. Meng Zhao. Yeah.
Okay, Hui or Jeffrey from Juniper. I don't know if this has been discussed on the mailing list or not. There is an alternative proposal where we, instead of advertising new behavior, we just advertising a flag to indicate this is terminal action. I think that in the best presentation, the proposal of the authors of the other proposed indicated that talk about the advantage of using a flag, which means that you do not need to define the new behavior for every endpoint behavior. I think that seems to be a very good point. So especially in this Spring working group, I'd like to hear people's opinion on this, whether we should use a flag or we should define a new behavior.
Yeah, so thank you for that. I did see, so when I sent this to the Spring mailer, I think in October, I did not see the reply by Meng Xiao so I apologize for that. We will get to that. There are various reasons why this was chosen as opposed to the flag, but we can discuss that for sure.
Excuse me, one question. Did you mean discussing in Spring or BES?
In BES.
Okay.
Ketan Talaulikar, Cisco. What I'd like to, and as Luke said, we will discuss with the authors of the other proposal. But I would like to just for the working group here point out that even though we are introducing a new behavior, the SID is the same. So we are not, this proposal does not require additional SIDs to be allocated in the forwarding plane on a per service basis. And one of the reasons this proposal is kind of better is because it scales better. We don't need extra SID for the fast reroute per service basis. But we can discuss more.
Thank you, Ketan. So this is clearly work for BES working group. The reason why this is discussed is I believe BES chair wanted to check with Spring whether this is okay or not, and also this is BES work. We did define the original SRv6 behavior for services, so it would be good for the working group to review at least the definition of new behaviors. So we would like to encourage people to have a look at the draft and comment whether this is okay or not for the Spring specific part. Okay, thank you.
Thank you.
Okay, next.
Hello, everyone. I'm Yuya Kawakami from SoftBank. So thank you for giving me time to introduce my new draft about the SRH reduction for SRv6 and MGTP6E behavior. This presentation is made in DMM Distributed Mobility Management Working Group on Monday. But so in this draft, I'm going to request the allocation of the new endpoint behavior. So let me explain this working group. Next slide, please. Before diving, so let me show the background of this motivation of this draft. So RFC 9433 defines a SRv6 map, SRv6 mobile user plane, which is enables the interworking between 3GPP-based user plane and SRv6 transport network in the mobile network operators network. And also this RFC defines behaviors which is required to translate GTPU, which is defined in 3GPP, and SRv6 defined in this working group. And another other internet draft about SRv6 map architecture. This draft defines a control plane for this SRv6 map, and also map SAFI draft defines a BGP SAFI to enable this control plane of SRv6 map. And in this draft, we like to focus on the end-to-end GTP6E behavior, which translate SRv6 packet from the internet side, and then so translate it into GTPU packet and forward to the G node B, who has a IPv6 address. Next slide, please. So let's recap the format of the end-to-end GTP4E and 6E behavior as a seed. In the case of the G node B, this G node B is a wireless base station, which is defined in 3GPP 5G reference architecture. And if the G node B has an IPv4 address, we can embed it. We can embed an IPv4 address inside the SRv6 seed. So in this picture, so there is an IPv4 DA, which indicating G node B IPv4 address, and also the parameters required to restore the GPU header, like TID and QFI, are stored in the args mob session, which has 40 bits. But in the case of the GTP6E, when the G node B have a IPv6 address, so we cannot embed IPv6 address inside the 128 bits of the seed. So we need to use two seeds to represent IPv6 address of the G node B, and also the parameters required for the GPU headers. Next slide, please. So motivation is we like to make this end-to-end GTP6E behavior hardware friendly. So because from the traffic from the internet side to the UE side, first ingress B, so MUPP in this figure pushes at least 2 SRH with 2 seed. Pushes one SRH with 2 seed, and then so forward to the SRv6 transport network. Then so egress B, MUPP1 needs to restore the destination address of the IPv6 or address of the G node B from the seed 0 and GPU header from seed 1. This behavior is very, very difficult to implement in some current hardware pipelines. So next slide, please. Our proposal is end-to-end GTP6 reduced behavior, which is optimized forms of this end-to-end GTP6E. The idea is just represent these two parameters within just one seed. So if there is no SRH policies, ingress B just push IPv6 header with the destination address of this seed, and then so ingress B MUPP1 restores the destination address and GPU header from just one seed, but it utilizes the control plane information to restore the complete information required to construct the GPU and the IPv4 headers. Next slide, please. So basic idea is, so please focus on the middle row of the figure. So we split the IPv6 address into the two parts, blue one and the yellow one. Then, so we first create a mapping table between IPv6, SRv6 locators and function, green part and the blue part. Then, so we embedded the yellow part into the seed. So this field is a zero-parted field in the MGTP6E seed, but we put yellow part into this field. So then, so egress B can restore the full information of the GTP6 header and also IPv6 address from just a single seed. So there are the two parameters. A is the prefix length of the G0 B, and it could be always 64 because IPv6 subnet is slash 64, and the B is the length of the locator and functions. This value could be 48 or 66, 64. That depends on the operator's deployment. Next slide, please. This slide shows the examples of when the A is 64 and the B is 64. So it takes much time to explain the, every steps of this procedure. So please focus on the mapping. And so PE1, so this is the egress P, has a mapping table. And then so they, if the P1 receives packet with a NMGTP6 reduced seed, so it looks up the mapping table using a green field and then gets the blue field. And also restore the remaining bits, yellow part, from the remainder bits, the right side last 24-bit seed, the yellow part, and then also create the, restore the full information of the G0 address, and also it can restore the GTPU header using the args mobile session 40 bits. Next slide, please. So this is the first draft. So I like to ask the community to give me feedbacks and advice and suggestions. And I already received individual feedbacks from community. So they suggest me to replace the order of the bit field in the NMGTP6 reduce. So the current design is just utilize that zero padded field to store the G0 address of the portion. But so they suggest me to replace the yellow field and the white field. And so it is very easy to restore the IPv6 destination address because the field is continuous. And we like to discuss this suggestion among our authors. And if it is reasonable, I'd like to reflect it to the 01 draft. And additional information, so I create the implementation in VPP and in Hackathon. So if you are interested, please test and try it. Thank you.
Thank you for taking the time to present in Spring. Again, it's not a work for Spring. It would be a work done in DMM. There are already lots of work Spring related. But it's for your information on feedback, so if you have feedback. Any comment? Oh, okay. Thank you very much for your time.
Thank you.
Next is encapsulation of BFD for SRv6 policy. I guess the speaker is Yesong Liu. Should I check? Or Changwan? Who is presenting? There is one more before. Okay, so hopefully this is a good one. So it's for map 6 segments for IPv4 service delivery. I guess the presenter is Guauzen. Yours the floor.
Hi, Chair. Can you hear me?
Yes.
Yeah, thank you. Hello, everyone. I'm Guo Zhen from China Telecom. I'm really happy having a presentation to be here. The draft name is for map 6 segments for IPv4 service delivery over IPv6 only underlay networks. Next slide, please. The document V6 ops framework IPv6 only underlay propose a framework in which IPv4 packets will be stateless translated or encapsulated into IPv6 once for transmissions across multi-domain IPv6 only underlay. So this document defines two new types of segments for segment routing. M46S and M46D segments, which are mapping rules-based IPv4, IPv6 conversion function running in PE nodes. Both M46S and M46D are called for map 6 segments and run in pairs. Next slide, please. In V6 ops IPv6 only underlay framework, each PE will be identified by at least one IPv6 mapping prefix. It will also have one or more associated IPv4 address blocks, which are extracted from local IPv4 routing table or address pool. In addition, a specific data structure called address mapping rule is defined to express the mapping relationship between IPv4 address blocks and the IPv6 mapping prefix of the remote PE. With this design, if the mapping rules of the remote PE are updated by the ingress PE, the mapping rule will give the forwarding guidance of IPv4 packet delivery in the IPv6 only network when the destination address of the IPv6 packet matches its IPv4 address block. The ingress PE will use the mapping rule to generate corresponding IPv6 source and destination addresses from its IPv4 source and destination address, and then generate a new IPv6 packet. Next slide, please. In the 4map6 seeds architecture, the locator field is a prefix allocated by operator to identify the node which instantiates the M46S, M46D seed. The function field identifies the behavior bound to the M46S, M46D seed. The argument field contains the IPv4 address prefix associated with the PE node. For the PE node, which is instantiated M46S, M46D seed, it's IPv6 mapping prefix for IPv4 delivery corresponds to the combination of locator and function fields. Generally, the number of seeds that can be instantiated by both M46S seed and M46D seed is equal to the number of associated by IPv4 address blocks. Next slide, please. Generally, the M46S, M46D seed nodes running in pairs for a specific data flow. One node is the ingress PE, donated by PE, and the other is egress PE, donated by PE2. All nodes located at the edge of the network need to announce their M46D seeds to other nodes. PE2 announces its ability to other nodes in the format of M46D seed in the SRv6 domain at the control plane. When PE1 receives the M46 D seed announced by P2, it will be stored in the local database. This database can store multiple entries, and each entry includes IPv4 address block, locator, function, device capability, and other information corresponding to the seed. The IPv6 mapping prefix, locator, and function represents the egress of the packet whose destination address is in the IPv4 address block. When PE1 receives a IPv4 packet, it uses the destination IPv4 address block to look for the corresponding IPv4 address block entry in the local database. When a new IPv6 packet arrives at the PE2 parses its locator part. When a new IPv6 packet arrives at PE2 resolves the locator part of the SRH in this packet layer by layer. Next slide, please. In a SRv6 network environment, the M46S, M46D seed needs to be advertised. The node advertises this seed, so the control plane together with the SRv6 add a behavior code point identifying the behavior of the seed. Similar to other type of seeds, the M46S and M46D seed can be distributed with and across domains via IGP and BGP or other approach. The advertisement method and reachability calculation are specific to the children routing protocol. Next slide, please. Okay, that's all. Welcome more comments and discussions. Thank you for listening.
Thank you. Chongfen?
Hello, Chongfeng Xie of China Telecom. As one causer, I want to provide some background information of this draft. Actually, IPv6 only is an important direction of IPv6 networks, and actually some deployment cases worldwide. However, for large-scale networks, in order to make sure the IPv6 deployment, we need to consider how to carry IPv4 traffic, not only IPv6 traffic, to make sure that the user can access IPv4 internet normally. So we adopt the stateless mapping approach. That is, IPv4 can be stateless mapped to IPv6. However, from the perspective of SRv6, we think that this kind of stateless IPv4, IPv6 conversion could be considered as a seed function. So we propose this draft. However, this draft still at the early stage is only 0 version. So we are looking forward to receive more comments and suggestions, and we'll improve it in the future. That's all. Thank you.
One question: have you presented this in base working group? Because since you agree that you need to advertise it, typically
not yet.
Okay.
We only present in spring. This is the first time.
Okay.
Okay.
So maybe you want to talk with the base working group chairs.
Okay. Thank you.
Or ask review at minimum.
Okay, that's great.
Thank you.
Okay, thank you, sir.
Ketan Talalikar, Cisco. Chongfeng, one clarification if you could provide. This is two V4 hosts talking to each other over an IPv6 only underlay. Is that correct?
Yeah.
So if that's the problem to solve, this is already solved with SRv6 underlay using 5549 or the newer RFC with BGP. So BGP can signal today IPv4 prefixes over an IPv6 underlay.
maybe we can discuss offline, but I think this problem is solved.
Okay, please send this answer to me. Okay, thank you.
Ketan, could you possibly send the reference to the list, Spring list? The reference to the documents that you mentioned,
Yes, definitely.
which would solve the solution. Thank you, Ketan. So hopefully next one is encapsulation of BFD for our service 6 policy. Thank you. I don't have a USB port, so available.
Hi everyone, I'm Yusung Liu from China Mobile, and today I will present the encapsulation of BFD for SRV6 policy behalf of my co-authors. Next slide, please. As we know, BFD mechanisms can use for the failure detection and also for the SRV6 policy. And for the hierarchical relationship of the SRV6 policy, the BFD session used to the segment list level. And when the BFD session done, the corresponding segment list fail. And all the segment list fail, and the corresponding candidate path fail. And all the candidate path fail, and the corresponding SRV6 policy fail. And so the BFD packet needs to carry the SRH to contain a list of the SRV6 seeds list with the BFD session. And this draft, we describe the encapsulation method, and the NK can be applied for the seamless BFD and the echo BFD. Next slide, please. And in this draft, we have proposed two modes of the encapsulation of BFD packet. And the first one is the transport mode. Transport mode, it means that SRH is inserted after the IPv6 header of a BFD packet. And we think that it can reduce the header overhead, especially when the detection interval is very short, and assume that in the same link we may have thousands of BFD detection packet. And the second mode is that encap mode, we call that. That means outer IPv6 header with an SRH encapsulated. And it can preserve the original complete BFD packet and only modify outer IPv6 header.
Okay, before you continue, I want to make sure of something as chair that I understand what you've just said. Are these two modes two different ways for the originator who is within the domain to generate the packet, or is this something you think is happening at the edge? Because inserting a SRH into an existing packet, if this is a BFD packet coming from outside the domain, is not compliant with the RFCs.
The BFD packet just within the SRV6 domain.
Okay, then that's fine. Thank you. I just wanted to make sure.
Okay, thank you. Next slide, please. When we use the BFD packets for the SRV6, we want to ensure the BFD packets can reach the tail end. When we use the unidirectional BFD packet, and it's from the head end to the tail end. When we use the echo BFD packet, it can first to the tail end and return to the head end. And the last seed in the SRV6 policy may not belong to the tail end. For example, we can use the n.x seed, or when we use the loose explicit parse. So we think that we should add the tail end address into the SR 0 position in the SRH. So make the BFD packet to the tail end of the SRv6 policy endpoint. And for the unidirectional packet, both in the transport mode and the in-cab mode, we set the tail end address into the SR0 position for the endpoint of the SRv6 policy. And for the echo packet, in the transport mode, we will add the SR0 position with the head end address. And we also set the tail end seed. We can use the end seed, or if we want to make the consistent with the reverse parse and the original parse, we can set the reverse bounding seed here. And with the in-cap mode, for the outer IPv6 header, we just set the tail end address in the SR0 position, and the inner IPv6 packet for the BFD is not changed. Next slide, please. And for the special handling of the UDP checksum, for the transport mode, we will calculate the UDP checksum, use the IPv6 header and the source address, and the destination address, we use the segment list 0 as the destination address to the pseudo header. And for the in-cap mode, we calculated the UDP checksum, just use the inner IPv6 headers source address and the destination address. Next slide, please. In China Mobile, we have run the lab interop test in last year. We have test both of the encapsulations for the BFD for SRv6 policy and with the Huawei H3C ZTE and Ruijie. Next slide, please. But that's all. Welcome to the questions and comments.
Greg, please.
Hi, Greg Mirsky Erickson. I apologize. Let's go to the first slide if we can. Yeah, no, substance. Yeah, here. We had a discussion about what BFD really monitors in segment routing. And I believe that we agreed that it monitors only candidate paths. So, and that's reflected in the working group document. So are you aware of BFD Spring document? You disagree that BFD can monitor policy?
I think when BFD run in the candidate path, it's actually in the specific segment list. Is that?
But the segment list, again, in general, includes instructions and candidate path. So how BFD monitors encapsulation instructions? If we look at RFC 5880, so in abstract, it says that BFD monitors their path between two systems and forwarding engines to a limited extent. So you are extending and changing their RFC 5880. So I think that basically your expectations are not really supported by what BFD does. Furthermore, so you mentioned, you use the terminology unidirectional BFD packet. Which of BFD modes do you imply?
This, in this draft, we called the unidirectional packet. That's just mean that the BFD does not return to the head end.
Well, first, it depends on which mode you use. Second, I would encourage you to use BFD accepted terminology, or at least map your terminology to BFD terminology, because there is no such thing as unidirectional BFD packet in RFC 5880. Furthermore, so it appears that you discuss BFD echo. Can you point to the document that defines applicability of BFD echo in segment routing?
Sorry, we can discuss offline in this discussion.
Yes, we can continue discussion, but as of now, I'm not aware of any document that defines the applicability of BFD echo function to segment routing. So I would suggest that before you start discussing it in your document, you need a document that group agrees how it's done.
In the BFD, I just to say we have proposed a individual draft about the BFD echo for the SRV6. I can send the draft link to you. Okay.
Okay.
So, okay. So can you take the action point to reply to Greg's comment on the list? Okay. Can you reply to Greg's comment on the mailing list? Okay. So that we can move forward. Zafar?
This is Zafar from Cisco. Just one correction to Greg comment. Greg mentioned that the BFD or any kind of detection mechanism run at the candidate path level. That's not correct. It runs at the segment list level because segment list is the atomic entity in terms of path that you're trying to verify, and candidate path can have multiple. So when you run at a segment list level.
Okay. We agreed that, again, you can call it, but that changes the RFC 5880. So first, then make the community agree that it changes, because the segment SR policy consists of candidate path and policy itself. So policy is not monitored by BFD. Someone can make assumptions, but BFD does not provide any mechanism to monitor anything outside of candidate path. That's what BFD is for.
Let's discuss offline.
From the Zhongguo Laboratory, I just want to know whether this draft defined exactly method how to make the reverse pass have the same seed list with the original pass. Is something like take the round trip or some special seed at the first beginning and the end? Okay, I think you understand my question.
Okay, and we can use the reverse bounding seed or the path segment to achieve that.
It's not defined in this draft, or it's in the scope of this draft, or some other.
Out of scope of this draft, we have also proposed two separate drafts to
I got it. Thank you.
describe that. Okay. Thank you.
Okay, thank you.
Thank you.
We are about a little bit late. So next one is validity of SR policy, candidate pass.
Morning, everyone. I'm Ran from RTE. Today, I would like to talk about validity of SR policy candidate pass on behalf of all the co-authors. Next, please. SR policy architectures are specified in IFC 9256 SR policy comprises one or more candidate paths of which at a given time, one and only one may be active. Each candidate path in turn may have one or more seed lists of which one or more may be active. When multiple seed lists are active, then traffic is load balanced overall. However, a candidate path is valid when at least one seed list is active. This candidate path validity criteria can't meet the needs of some scenarios. This document defines the validity control parameters and the candidate path to control the validity judgment of candidate paths. And it doesn't change the segment list invalidation rules defined in SR policy architecture as specified in FC 9256. Next, please. This is the motivations. The candidate path validity criteria defined in FC 9256 can't meet the needs of the following scenarios. The candidate path 1 carries a total of 200 megabytes of traffic. Within the policy 1, the flow-based hashing over this it's each segment list with ratio 15%. That is, each segment list will carry 100 megabytes of traffic. And this time, if one of the segment lists is invalid, the remaining segment list can't carry 200 megabytes of traffic. However, the candidate path 1 is still active. Next, please. The head end will be informed the validity control parameters and candidate paths via BGP, PCEP, and configurations. And the details of the protocol extensions have been defined in separate documents. And we have do some presentation in the on the last IETF meetings in PCEP and IDR working group. And this document defines the following validate control parameters and candidate paths to control the validity judgment of candidate paths. The first one is segment SL quantity. One octet field, which indicates the minimum number of valid segment lists and the active candidate paths. 0 indicates no special requirement for SL quality. It still follows the SR policy architectures, and it indicates that at least one segment list is required to be active. And 0xFF indicates that the candidate path is considered valid only if all the segment lists are valid. When the number of valid segment lists is greater than or equal to this field, the candidate path is considered valid. And the second one is a valid segment weight for octet field, which indicates the minimum value of the sum of the weights of the valid segment list and the active candidate path. The value is 0 to 0xFFFFFFF, and 0 indicates no requirement for weights, and 0xFFFFFFF indicates that the candidate path is considered valid only if all the segment lists are valid. And when the sum of the weights of the valid segment list and the candidate path is greater than or equal to this field, and this candidate path is considered valid. Next, please. Comments welcome. Thanks.
Any comment? No? Okay. Thank you.
Okay, thank you.
Wamo, up to you. You have all your time. So for that one, you're supposed to have 5 minutes. If you use more, you will use your own time for your next presentation. Up to you.
Hi, everyone. I'm Huai Chen from FutureWay. I'll talk about the SRM plus FR extension. Next page. I would like to thank Joe, Andrew, Yao, and Jeff for their comments and the suggestions. So the updates to the previous version includes aiding description on how to determine whether a seed is a failed seed, and aiding reference and some editorial changes. Next page. So let's see how we determine a seed is a failed seed. So basically, if there is a RIP or FIB entry for a seed, and then that entry for that seed is removed after SPF. So if these conditions satisfy, then we can determine that that seed is a failed seed. So for example here, node N failed. So the first arbitrary endpoint P1 on the path through node N. So after N failure, after convergence on the failure, P1 will determine that seed N is a failed seed. So in this case, P1 will provide protection of the failure of node N or seed N. So basically, P1 will pops the seed N and then just send a packet using the top seed of the packet along the sorted path. So that's the extension. So next page. So comments are welcome, and also we consider maybe we can have an adoption call.
Well, before any adoption call, we would like to have some review on the list and comments.
Okay. Yeah.
For people to have read it and comment.
So go to
No comment? Ketan? Okay.
Ketan Talalikar, Cisco. I just wanted to point out that the working group already has a draft which solves this problem, and this is an alternate solution. So
yes, I noticed that. Basically, I give some history.
you should probably remind it. I mean, suggestion to remind it every time you present this.
Yeah. So basically, that's a long time ago, and then there's a draft for this problem, and we almost at the same time we have a draft, and then so because two drafts for the same problem, and then should merge that I propose a merge, and then the replies, and then we can go in parallel. So that's a reply I get. So this proposal is different ways, and then maybe.
So
we can discuss on the list. It's okay.
Yes, maybe the first question is why do we need a second solution?
Yeah, I think this one is simpler. It's simpler than the previous one. For example, the previous one needed some kind of timer, so hold some folding entry, and then that's I think in the draft we described that one. This one is similar than the previous one.
Okay. In general, we are not looking for multiple solutions for a problem, so you will need a clear benefit.
Okay, discuss in the list or
yes,
either in the draft in more details. Okay.
Yes, in the draft, and maybe you can introduce your draft on the list to say, well, I'm proposing a second solution because, and then you introduce to start the discussion. Yeah. Thank you. Next.
Yeah, next one is following. So I'll continue talking about SR plus binding protection architecture. So this includes distribution of binding protection information and the procedures for the protection. Next page. So I define 3 seed lists for binding seed of a node on each of the SR paths. So I'll explain those 3 lists through examples. So in this picture, we have 3 paths. So path 1 is in domain 1 in single domain. Path 2 and path 3 cross 2 domains, domain 1 and domain 2. And then for path 2 and path 3 cross 2 domains, and then we have border node B3. So on this border node has binding seeds. So for this border, we have alternate border node B4 to this B3. So for all these 3 paths, they represented by seeds, different type of seeds. So for node seeds, or for node X, is represented by seeds X. For adjacency seeds, for the adjacency from node X to node Y, is represented by seeds -X -Y. For binding seed of node X, is represented by B seeds -X. So here, path 1 is represented by a list of seeds, and then there's a binding seed, seed B1, and then B1 associated as list A. And then similarly, we have path 2 and path 3 all represented by the seed list. So seed list A represent the active path segment for the binding seed. For example, here, for binding seed B seed B1 on the path 1, so this active list is just the list contains seed B2 and seed P5. So the second list is list C, represent bicarb path segment corresponding to seed list A. So from list A, we can get list C in the way that if the first seed in the list A is a node seed, and then the list C is the same as list A. For example, here, for beta seed B1, so list A, the first seed is a node seed, seed B2. So in this case, list C is the same as list A. If first seed in the list A is the adjacent seed, so we can get list C, just replace that seed with the node seed of the remote node of that adjacent seed. So for example, here, for path 3, we have B seed 2, B3. So in list A, the first seed is the adjacency seed for the adjacency from B3 to Q4. So we just replace that seed with the seed Q4, and then we get list C. Then after list C, we need to get list B. List B represents the bicarb path for the failure of a node with binding seed. So we have different case for list B. For single domain case, list B is the same as list C. That's simple. We have example here. For example, for path 1, so is in one domain. So for the B seed B1, so the list C is the same as list C. So for paths across 2 domains, we have two different cases. One case is that 2 domain is owned by one provider, and then the other case is that 2 domain is owned by 2 different providers. For the first case, so list B is the node seed of an alternate node, such as seed B2, plus the seeds in the list C. So for example, for the path 2, cross 2 domains, so for the B seed B3, and then the list B is seed B2, B4 plus seed Q3 and seed Q. So the second case is that 2 domain owned by 2 different providers. In this case, the seed list B is the, the node seed of alternate node, for example, seed B4 plus binding seed of that alternate node, for example, B seed B4. And then the binding seed of alternate node is associated with the seedless 3. So that's the backup list B for the part for the node cross two domains and then owned by two providers. So with all those lists, and then we can describe the distribution of binding protection information. Next page. So suppose that we have a node N, binding seed of that node N, this binding seed associated with list A, and then we can distribute information for 3 cases. In simple case, in single domain, so the binding protection information will contain the binding seed of node N, and then seed list B, and then the ID of node N. So this binding information will distribute to the label node of node N. In addition, this information will also distribute to the first upstream endpoint node of node N if that node N is loose hop on the path. So here we give an example for B1. And then for the second case, 2 domain owned by 1 provider. So in this case, the binding protection information includes the binding seed of that node N and list B. So in this case, list B contains node seed of that alternate node plus the seeds in the list C. And then the ID of that node. So this binding information will distribute to the label node. In addition, if it also will distribute to the first upstream endpoint node, if node N is loose hop. So the third case is that 2 domains are owned by 2 different providers. In this case, 2 pieces of information were distributed. So the first piece of information includes binding seed of an alternate node and list C. So that means the binding seed of that alternate node associated with list C. So this piece of information will distribute to alternate node, for example, B4. So the second piece will distribute to the second piece of information includes binding seed of that node N and the list seed list B plus the ID of node N. So this piece of information will distribute to the label node of node N. In addition, this piece of information will also distribute to the first upstream node if node N is loose hop. Next page. So after this information is distributed, and then we can provide protections for different cases. So this just shows the case for 1 domain case. For example, 1 domain for pass 1, B1 failed. B1 has a binding seed B1. So when B1 fails, P3 is the label node will detect the failure. So P3 will replace, will pop seed BN and then replace binding seed B1 with seed list B, and then forward package along to the next seed without going through failed node. So that's before the failure, before the convergence. After convergence, the first upstream endpoint node P1 will determine a failed seed, which is the seed of B1. In this case, B1 will pop seed B1 and then replace the binding seed of B1 with list B, and then just forward the packet using the forward entry for seed B2 along the shortest path. And then in this case, P1 will send packet to P4 because P4 is on the shortest path. Next page. So this is just to give more examples for different cases. So this case is for 2 domain owned by one providers. In this case, so B3 with 2 binding seeds. One is for pass 2 and the other is for pass 3. So we just give for one case, for example, for pass 2. So when B3 fails, B1 will detect failure. So B1 will pops the seeds onto the binding seeds and then replace the binding seed B3 with list B. So at this time, the list B is represented the protection path for the failure of B3. So it includes the seed of B4 and then seed Q3 and the seed C. So replace this seed and then forward packet according to the tuber seed without going through B3. And then the packet will go send to B4 and then Q3 and to C. So next page. So this gives another example. So this is the case for 2 domains owned by 2 different providers. In this case, when B3 fails, B1 will detect the failure of B3 and then will pop some seeds onto the binding seed of B3 and then replace the binding seed of B3 with list B. So in this case, list B contains seed of B4 and then binding seed of B4. So this package will send them B4. B4 will pop is seed B4 and then replace B4's binding seed with seed list C. And then the package will send along pass Q3 and C. That's for pass 2. For pass 3, because the binding seed is another binding seed, so for pass 3 is in green. So B1 will detect failure of B3, and the B1 will replace binding seed 2 B3 with list B. So this list B will be load seed B4 and then another binding seed of B4, B seed 2 B4, and then send it to the package to B4. B4 will post his seed B4 and then replace B seed 2 B4 with seed list C. So this will, at this time, the seed list will be Q4 and C, and then package will send to Q4 and then to QC and then to the destination. Next page. So I welcome any comments.
Any comments? In the meantime, I have one. So what we need is a discussion on the list to see if people are interested or not.
Yeah.
And probably what would be helpful to trigger discussion and to trigger interaction between the working group and yourself would be to reuse the terminology that we use in the working group.
Okay.
So for example, the one defined in SR architecture and SR policy.
Okay.
Because you tend to define new terms, and it's not easy for people to understand what you mean by new terms. So, yeah, example, in many parts in your draft on your slides, you use replace B seeds with the B seedlings.
Okay, okay. Yeah.
There is no such replace.
Yeah.
So for
Yeah,
SR,
I use
yes,
the
but for
terminology.
SR6, it's either end caps,
Okay, okay.
which are consequences, or insert, which are other consequences, as
Okay.
Joel said. But yes, please use the same terminology,
Okay, yes.
because it will help people to interact on progress the draft.
Okay, thank you. Yes.
Because if you define new terms that nobody understands, it's difficult to discuss, and you will have less comments. And
Yes, I synchronize the terminologies. Thank you.
Thank you. Ketan, you're on the queue. Not on my side, but no. Okay.
Okay, thank you.
So if we don't have comment, we give you back 6 minutes, which is incredible. So thank you for every speaker to have respected their time slot, and thank you for the meeting. And please review the minutes and comment if you disagree. Thank you. Bye. We're on time. No, 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 no. Just.